In this video, we're going to go over something called Hess's law. We're going to hold off on AP type questions related to this law for this video and for the problem set that goes along with this video. We're just going to focus on the law because it's probably a new topic for most, if not all of you. And then we'll add the equilibrium stuff into it as we go through Unit 2. So Hess's law is a law that says we can take individual reactions and manipulate them, add them together to get an overall reaction. So you can switch the side, you can reverse it, you can multiply by a number, you can divide by a number for the coefficients. You can't change the formulas or the elements or anything like that, but you can change the coefficients just like you would for balancing. We're also going to focus on delta H for right now, which hopefully you remember from first year chem, but if you don't, it's honestly not that important. We are going to go over it this year. Delta H has to do with heat of reaction. We will go over it later. It's just the easiest one to use with Hess's law. So when we add equilibrium into Hess's law, it gets more complicated, and we'll talk about that later in this unit. But to keep it easy while we're learning it, I'm just going to do delta H. So for delta H, whatever we do to the reaction, we're also going to do to our delta H value. So let me show you what I mean by that. So this is there's no real notes for what to do here. You just have to practice it, which is why we're going to take a class to do so. But the first thing I would do is find something in your overall reaction, which is this, that only appears once in your individual reactions. So for example, I'm not going to pick Cl2. because Cl2 shows up here and here, okay? But if I pick PCl5, that only shows up in one place. So what I need to do is make this PCl5 and this one match. So the two things you want to check are the side of the arrow and the coefficient. So here, PCl5 is before the arrow, and it is here too, so we can keep it the same direction. But we need to divide by 4. So I'm going to take this reaction and divide it by 4. And again, whatever I do to the reaction, I have to do to delta H. So that means I'm going to get PCl5 gives me 1/4 phosphorus plus 10 over 4, and you can reduce that if you want, or you can just reduce it at the end, Cl2. And then we're also going to do the same thing to our delta H value. So you take 3438 divided by 4. Now let's do PCl3, because PCl3 shows up here and here. So again, check the side of the arrow. This one is on the right side. And we need to divide by 4 again. Doesn't always work out that way, but for this one it does. So I'm going to line up the arrows because it's easier to add the reactions together if I do that. So we're going to divide by 4, 1/4 plus 6 for Cl2. And again, you can reduce those fractions if that makes you uneasy. That is totally fine. You can also just wait till the end. And then we divide our delta H by 4. Okay, so now I'm going to check my work. And in order to check my work, I'm going to add these reactions together. Now you can see that I have 1/4 P4 on both the before arrow and the after arrow, so those will cancel out. And then here we have 10 over 4 Cl2, 6 over 4 Cl2, okay? So that means we can cancel out 6 over 4 Cl2, and when we subtract them, because that's what we're doing when we cancel out, we end up with just 4 over 4, or 1. So then we have left over PCl5 gives us PCl3 plus Cl2, which is exactly what we wanted here, okay? So you just want to add them together to make sure it checks out. Once you do that, you can just add your delta H's together and you will get the delta H of the overall reaction. Now keep in mind that one of these is negative, so you want to keep that in mind when you're doing this. Be careful with the positives and negatives. That's going to end up being very important. Okay, so that's it. That is one way we can use Hess's law with delta H. When we get to the equilibrium version of Hess's law, it's the same idea with the adding all the reactions together. It's just that the rules for what you do to the equilibrium numbers are different from what you do to delta H. So we'll get to that later. For now, let's just try another one. So this one you'll see has 3 individual reactions. And my guess is we're going to need all 3 of them. So I'm going to start the same way I did last time. I'm going to look for something, C2H4. I'm going to check and make sure it's only in one place. It is. So C2H4 is before the arrow and it has a 1 coefficient. So we're actually going to keep this one the same. And I just like to write what I'm also doing to delta H to keep myself organized, because a lot of what you do in chemistry is just organization. So then I'm going to rewrite this one exactly as is. Now, look at C2H6. C2H6 shows up here, and it shows up here, and that's it. It's not in any of the other individual reactions. We have to get C2H6 on the other side of the arrow, and we need to divide by 2. So I'm going to write flip, divide by 2. And I'm going to write that for my delta H's as well. So I'm going to go ahead and do that to the reaction, and then I'll explain what to do with the delta H after. So make sure you remember to divide by 2 and flip around the arrow. So now we're going to put this stuff before the arrow and also divide by 2. So you're going to get 2 CO2 plus 3 H2O. And then all of this goes after the arrow now. And also divide by 2. Remember, you're only dividing coefficients, not any formulas. Okay, for the last reaction, we have H2 here and H2 here. So they're both before the arrow, but we need to divide by 2. H2 plus 1/2 O2 gives us H2O. All right, so before we mess with the delta H's, let's go to make sure our equation is balanced or added together correctly. So here we have 3 H2O. We have 2 here and 1 here. So 3, 3 on both sides. So we can cancel those out. Let's take a look at the O2s. We have 1/2 here and 7/2 here. So I'm going to cross this one out and change this one to 3 just to get rid of the reactions, make it a little bit easier on me. And then you can see we have 3 O2 here to cancel out with this 3 O2. So the O2s are completely gone. We also have 2 CO2 before and after. And so that leaves us with C2H4 plus H2 gives us C2H6. And that is what we wanted. So now that we know we did the equations correctly, let's go back up and do the delta H. So one of them we kept the same. One of them we flipped and divided by 2. So when you flip a reaction, you change the sign on the delta H. Change the plus minus on delta H. So here we will go to positive 1560, but also don't forget you need to divide by 2 there, okay? That's why I try to keep track of everything. So now it's going to be positive 780. And of course, you don't have to write the positive sign, but just to reiterate the point. And then we have negative 285.8 divided by 2. And then we'll just add all of those together. So our overall delta H comes out to this number here. So what I'd like you to do now is pause this video. There are 2 more practice problems on your notes. Try to get through those 2. I start off with one that's just 2 reactions and then one that's 3. Give them a shot, try your best, and then come back. All right, I'm going to solve these. I'm going to go a little bit more quickly because you should have already finished it. I see that this needs to be flipped and multiplied by 2. And then it looks like this one's going to stay the same. CO2's cancel. 4 of the H2O's cancel, so this one won't go completely away, but we'll only have 2 left. And then 5 of the O2's cancel, so we'll just have 1 O2 left here. So that comes out to be and that is what we wanted. So then we will have delta H for the first one will be 685.5. We flipped that reaction, so that number delta H is going to become positive and multiply by 2. And then this one stays the same. So when we add those together, you get this. If you haven't tried the next one, go ahead and pause the video and do that one. Try it on your own first, and then come back and see the answer. Okay, so we have, I'm going to start with CH4. It shows up here and nowhere else in the individual reactions. So this one is going to flip. And since this is far away, I'm just going to write it here to remind me. And then NH3 here and here. So we need to flip it and divide by 2. And then for our last one, we have HCN. And it is on the correct side, but we need to divide by 2. Let's add them together just to be sure we got the right thing. So we have carbons that cancel. Oh wait, this should be, sorry, 3/2, not just 2. And so, oh no, that was right. Sorry, I'm looking at the wrong one. So 2H2 plus 3/2 H2 on one side. We have 1/2 here. So this would become 1. And then the N2s will cancel. So you end up with CH4 plus NH3 gives you a total of 3 H2s plus HCN, which is what we wanted. So now let's go ahead and do what we need to do to these delta H's. The first one, we're going to flip 91.8 and then divide it by 2. So 45.9. And then the next one we just flip, so it becomes positive 74.9. And then the last one we just divide by 2, so 270 divided by 2. And then we go ahead and add them together. Okay, that's Hess's law. We will practice it in class as well.